demo of our senior design project, which is a mobile app developed using React Native and uses near-field communication technology to configure IoT devices. And in this demo, the IoT device that we're going to configure is an OpenWRT router. So what I have on my screen is a terminal to show you what is happening on the back end of the application and my mobile phone. So let's start by opening the app. It's just building right now. Okay. So the first page of the app is a sign-in page. Anyone can sign in, but the authorization to the next pages of the app depends on the content of the NFC tag. So let's start by putting in my credentials. And when I click continue, it's gonna ask me to scan the NFC card. And I scan. And as you can see, what I am reading from the NFC tag is this fully encrypted data. So as you all know, there are available mobile applications on App Store and Google Play that can read and write to NFC cards. And in that case, if they read our card, this is what they're going to get. So all the data, all the content, and the header of the content of this is protected. What our application does is it has the specific key to this encryption. And so we decrypt the text, and what the content has is a header and the HTML code that the application will render. This HTML code can be anything, but this header is a standard from our side. So what this header has is the name of the device and the connectivity type. The connectivity is important to be specified because that tells our application how we can communicate with a device. And in this case, since it is a router, we are communicating through SSH. And then we have here the number of devices paired and devices paired ID and password. Only authorized people can have access to the app, and they are specified here. Since I am the first one to scan this tag using the app, there's no admin yet, and there are no other users yet. So when I click on continue, it's going to ask me to scan the card again. And that process writes to the NFC tag that I am now the new admin because I am the first user who scanned this tag. And as you can see, devices paired ID is Johan, my username, and the password. The password is hashed on top of this fully encrypted data. So we have hashing and encryption to secure the data that we are storing on the NFC tag. That directs us to the web view wherein we can configure the device. In the connected devices, this is real time. Therefore, I'm going to connect my other laptop and you're going to see it pop up on this page.
Hello everyone. As you can see on this page, along with the SSID, we have the list of connected devices and the routing table, which shows the destination IP addresses of the packets and the network traffic shown at the bottom. The connected devices table is dynamic, which means that when a device connects or disconnects, it shows immediately, as you can see now. The network traffic section shows the monthly and daily average of received and transmitted data in megabytes, and it shows the average rate in kilobits per second. This is important as it can tell us if the network is busy and can give us an insight into why there might be a decrease in the speed of the network, for instance. Now we will move on to changing the SSID. Here we can see that the router's original name is My Home Wi-Fi. We can change the name to, let's say, FYP Wi-Fi, and then we hit on apply, and it shows this message saying that we need to restart the router for the changes to take place. So we reboot, and the Wi-Fi settings should change.
As you can see, the router's SSID has been changed from My Home Wi-Fi to FYP Wi-Fi as shown over here. Now we're going to show you a demonstration of logging in using an unauthorized user, so a credential that doesn't exist in the application array. So I'm going to do this by logging using my own credentials. I haven't been added yet, so I'm going to attempt to log in. My username, and I put in my password. And once I do, I can scan the NFC card. And then I get this pop-up that says alert not a valid user because my username or password has not been added into the username array of the application. As you can see here, Joanne, her username being the admin and her password hashed into the application is the only username and password that is stored into the NFC. So in order for me to be a valid user, the admin Joanne needs to add me.
So only I have access to the device right now since I am the admin. But the admin can add users for authentication. So I'm gonna log in the same way. It grants me access and took me to this page. Only the admin has access to this page where I can add users. And I'm gonna add Muhammad.
So as Joanne is adding me as a user, she's using my username and my password that I provided her to add me as a user. Because she's the admin, she would need to scan the NFC as shown to write into it my username and password information, credentials. So this gives me the authority to be able to log in as a user. As you can see in the back end of the NFC, we have the device's paired ID, Joanne and Muhammad, myself, as long with our passwords being entirely hashed. And the whole NFC content is on top of the hashing is also encrypted as a whole. So this allows me to access the NFC content and allows me to access the device that's paired to it and to control it as however I need. For example, now that I am logged in, I'm gonna change the password for the router. So if I were to change the password to something else and then hit apply, and then it tells me that the router needs to restart. So I click OK. And in this scenario, I'm gonna restart the router manually to give a different test case. So I'm gonna restart the router. And as I turn it off and on, you can see that we got a little pop-up at the end that's saying that the application has been disconnected with the router. So we will go on to the settings and we will try to connect with the router again. And then when we do, we will notice that it will tell us that the password is incorrect because we just changed the password. So I'm gonna enter the password that I changed the router to. And this is one of the things that our application allows the communication and configuration of the router. So now I can go back into the application and I can log in and scan my NFC. And once I do, as you can see, it gave me all access to the application and I can configure it the same way as the admin. Any other user can configure it similarly. And this is kind of a demonstration of adding another user into the application.
We have two other tags. We support connection for Bluetooth and for Wi-Fi. Okay. Now I'm gonna exit this app. We will start with Bluetooth. Okay. This Bluetooth already has Kinana as admin and Suj as another user. Let's log in as Suj. I only know this because I own the tags. I click continue and then I scan and I have access. Because as I said, Kinana and Muhammad, and these passwords. And connection type is Bluetooth, as you can see on this decrypted text where we're printing the header. We have Kinana and Muhammad and Bluetooth for connectivity. We have that one. Now we will try with the Wi-Fi. No one is here yet. Let's log in as Kinana. I scan the same way. You can see that the connectivity is Wi-Fi. I'm gonna scan. Kinana is the new admin. So to conclude, this demo shows how our mobile app is application and device agnostic, meaning that nothing is stored on the mobile app itself. Instead, they are completely from the NFC tags.
Our application can render any HTML code you supply it, which is stored on the NFC tags, as long as it follows the standard that we set, which contains the header needed, followed by the code itself.
And we showed on our demonstration that only authorized users can have access on the device, and their username and password and even the content is fully hashed and encrypted on the NFC, which makes it completely entirely safe to use. Thank you.
Oh,
Thank you.